Hello, and welcome to Data Unlocked, the podcast where we explore the world of data, analytics, and technology shaping the future of businesses. I'm your host, and today we're diving deep into one of the most exciting, yet often misunderstood areas in tech: data engineering. We'll uncover what data engineering is, why it matters, the key tools and practices, and how it connects to the booming fields of data science and artificial intelligence. I'll also share a few real-world stories and answer some of the most common questions people ask about this field. So grab your coffee, sit back, and let's jump in. Let's start with a simple question. Where does all the data that powers AI models, dashboards, and business decisions actually come from? Behind every data science project, every recommendation system on Netflix, every fraud detection system in banking, there's an invisible layer of data engineering. Think of it this way. If data science is like a chef preparing a meal, then data engineering is the farmer, the transporter, and the grocery store making sure the ingredients are fresh, available, and ready to cook. Without the farmer, the chef can't cook. Without data engineering, there's no reliable data for analytics. So, what exactly is data engineering? Data engineering is all about designing, building, and maintaining systems that collect, store, and transform data so it's usable. It covers data ingestion, which is pulling data from sources like databases, APIs, or streaming platforms. It involves data storage, which means organizing it in data lakes, warehouses, or modern platforms like Snowflake and BigQuery. It also includes data transformation, cleaning and shaping raw data so it's analysis ready. And of course, data pipelines, which are automated workflows that move data reliably from point A to point B. At its heart, data engineering ensures that organizations have the right data at the right time in the right format. Now, one of the most common questions I get is, how is data engineering different from data science? And here's how I like to put it. Data scientists spend their time analyzing data, building models, and generating insights. Data engineers, on the other hand, make sure that the data exists in the first place, that it's trustworthy, and that it's accessible in a usable form. Without engineers, scientists would spend 80% of their time cleaning up messy spreadsheets. With engineers, they can actually focus on insights and innovation. Why should we care about data engineering? Well, there are a few reasons. First, trust in data. Without strong pipelines, businesses risk making decisions on bad or incomplete data. Second, scalability. As companies grow, so does the volume and complexity of their data. Data engineering ensures the system doesn't collapse under pressure. Third, fueling innovation. From predictive analytics to machine learning, none of it works without clean, well-organized data. Let me bring in a story here. I recently spoke to a data engineer who worked at a retail company. They built a machine learning model to predict customer churn, but the results were completely inconsistent. Some weeks it looked great, other weeks it was way off. After some digging, they found that the data pipeline had been dropping records whenever their API source got overloaded. Imagine that. The model wasn't failing because the math was wrong, but because the data foundation was cracked. Once the engineers fixed the pipeline, accuracy shot up by 30%. The moral of the story? A model is only as good as the data flowing into it. So what tools do data engineers use? The essentials include programming, with Python and SQL at the core. For handling massive datasets, big data frameworks like Hadoop and Spark come into play. For orchestration, tools such as Apache Airflow, Prefect, or Dagster help schedule workflows. For real-time data, streaming systems like Kafka or Flink are widely used. On the storage side, we have data warehouses like Snowflake, BigQuery, and Redshift, and data lakes on S3 or HDFS. But here's something people often ask me. Do you need to know all these tools to become a data engineer? The answer is no. What you need is a strong foundation in SQL, a solid programming language like Python, and an understanding of how data moves from source to storage to analytics. Once you master the fundamentals, you can learn new tools as the need arises. Another important point, tools alone aren't enough. Data engineering also requires best practices like version control, monitoring, testing pipelines, and documenting everything. It's both an art and a science, balancing performance, cost, and complexity. Now, where is the field headed? We're seeing the rise of data ops and automation, bringing DevOps-style practices to data pipelines. Real-time analytics is gaining traction as businesses want insights instantly, not next week, which makes streaming increasingly important.